In this video, I'm going to show you how to use Wireshark to capture attack traffic from Kali VM to Windows VM. And so here is what we are going to do here on Kali VM. And so I'm going to the attack folder. Okay. And so here is our attack Python script. So if we use a text editor to open this file, and then the file actually is here, right? And so the file is here. Okay. And so you can see here, this is our attack script. So please pay attention to here, the payload here. And what this is doing is we are constructing an attack string here. And within this string, then we have the shell code. So this is the malware code. This malware code will run on the victim computer. And what this malware code does is it will collect back to this Kali VM. Okay. And so we need to actually run a server using this netcat to capture the collection that is going to collect back. And so let me start another terminal and run this netcat. Good. Okay. So everything's good. And so if we want to run this attack, we just need to do this, right? And but I need to prepare Windows now. And so here, as we did it before, here we are going to run the vulnerable chat server. Okay, so this is the vulnerable chat server here. So let's run it. Okay, so now you can see here, this vulnerable chat server is running. And so now let's start Wireshark. So we are going to use Wireshark to capture the attack traffic to this Windows VM, but actually we will capture all traffic to and from this Ethernet. Okay, so you can also see that IP address over there for the Ethernet adapter. So we just actually double click, then Wireshark begins to capture the traffic to that Ethernet adapter. Okay, and so now let's perform the attack from Kali VM. So everything's ready here. And so let's deploy it. Good. Let's see anything here. Nothing yet. Let's wait. But here you can see this chat server already received that collection. Okay. And if we go back to the Kali, now you can see the attack was successful. Good. Great. And then we come back. Now you can see this Wireshark also captures a lot of traffic. So let's stop it. So the question here is you can see we have quite some traffic here, and but really I only care about the traffic between the Kali VM to this Windows VM. And as we recall, the Kali VM has an IP address of 10.0.2.14, and this Windows VM has an IP address of 10.0.2.13. So to look at only such traffic, here we can actually set up a display filter. And how do we do this? Actually, there are a lot of tutorials online. So you can see here, right? And here, this is about the capture kind of tutorial. And we can also do other things. So if we go back, oh, here. So let's go to here, go to the home of this guide, and if we search display, and you can see here is this is a building display filter expressions. Let's click here, and so you can read through this guide, and then now you can see here, and we have actually a lot of fields here we can use to set up the display filter so that we only look at the traffic we want to look at, right? And you can see here the IPv4 address, and so classless interdomain routing notation can be used to test if an IPv4 address is in a certain subnet, for example. This display filter will find all packets in this one, okay? And but actually we can also do this, and so we can do this one, IPv4 address, right? And we can do this. So I copy this to here, and I want to actually look at the traffic that is related with the CAD VM. Okay, so that is 14. Good. So now you can see we only show traffic that involves this CAD VM. Okay, and so if you look at the lens information, this one looks very big, and actually we sent a long message. So let's look at this. Now you can see here actually this is the attack message. If we go back to here, right, you can see this is how we construct this payload. And first, then you should see knock space, something like this. Then you should see actually 2002 is. The next, you should see an address like this. Next, you should see 32C. Then we will see our shellcode. Okay, so basically, let's look at uh, the traffic in Wireshark and then look for C here. Then, so then we should be able to see the shellcode. Now, if you look at the shellcode, you can see it starts with a BED9. Okay, BED9. Okay, let's go back here to look at this. You can see here, this is very long, and we actually cannot see all the message in this one packet. So that means the message was sent in another message because the message was too long. Part of the message was sent in this packet. Part of the message was sent in this packet. Okay, if we go down, okay, now we can see C here. Good. So now you can see C here, right? C, 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 C. Then we know actually after C here, that's the first one here. Then we should see BED9. B9. Okay. BED9, B9. Yes. Now you can see the attack traffic. So this is the basic idea of using Wireshark to perform packet capture. Then from the captured traffic, actually you can find the malware code. And so this is one way of intrusion detection. If you know somebody using a well-known shellcode, and you can look for such shellcode in the packet in the network traffic. If you find such shellcode in the traffic, it means you detect detect this attack.